Welcome back. Let's continue our discussion on factoring quadratic equation. The first problem that you see on the screen is very simple. All you have to do is expand what is within the bracket using a plus b whole squared algebraic expression. And from there, the problem is very, very simple to solve. So let's go ahead and solve it. So we have 2 times x plus 1 squared minus 5 equals 27, right? So if we expand what's within the bracket, it should lead us to x squared plus 2x plus 1 minus 5 equals 27. Let's multiply by 2 throughout what's inside the expression. Then we get 2x squared plus 4x plus 2 minus 5 equals 27. This leads to 2x squared plus 4x minus 3 equals 27. If we subtract 27 on both sides, then we get 2x squared plus 4x minus 30 equals 0. As I've always said, if you can simplify a quadratic expression, please do by all means, because it simplifies the problem. So we have 2x squared plus 4x minus 30 equals 0. 2 remains a common factor. So let's take 2 out of the bracket, which leads us to the following expression. 2 is irrelevant anymore, so we can disregard it and solve only what's within the bracket. So we now have to get negative 15x squared, and we have to get plus 2x. So if you multiply plus 5x times negative 3x, we get negative 15x squared. If you add these two terms, then you get 2x. So if you substitute 5x minus 3x in place of 2x, then we get x squared plus 5x minus 3x minus 15 equals 0. So if you split this term into halves and take x as a common factor in the first half, then you end up with the following expression. In the second part, if you take negative 3 as a common factor, then you end up with negative 3 times x plus 5. And this whole expression is equal to 0. If you combine the terms, then you end up with x minus 3 times x plus 5 equals 0, which leads to x equals 3 or x equals negative 5. It's just that simple. So let's go ahead and solve the second problem. What I like about the second problem is it doesn't actually give you an actual quadratic expression. Instead, what it asks you is the key component of a quadratic problem, that is to figure out the two terms that gives you the root of the quadratic equation. So the problem states 2 consecutive positive multiples of 3 have a product of 54. What is the sum of the two numbers? So let's write all multiples of 3, because that's what it says. So we have 3, 6, 9, 12, 15, 18, and so on. If you take 2 of these consecutive numbers and you multiply, you should get 54. If you multiply 3 times 6, that's 18. Let's do 6 times 9, that's 54, and that's what we want. But that's not what we are asked to solve. This is the first step in the process. 6 times 9 is 54. So if you sum those two numbers that gave you 54, then you end up with 15. And that's what the question is asking you to solve. Isn't that simple? All right, let's continue. So we have 3x squared plus 10x equals negative 3. As always, I said, try to make a quadratic expression with all the terms on one side. And the only way you can do it is to add plus 3 on both sides, which should give you 3x squared plus 10x plus 3 equals 0. So we want 9x squared, and we also want 10x, right? So if you do 9x times x, then that'll give you 9x squared. If you add 9x plus x, that will give you 10x. So substitute 9x plus x in place of 10x, which would give you 3x squared plus 9x plus x plus 3 equals 0. If you split this term right here in two halves and you take 3x as a common factor, it'll give you 3x times x plus 3. And you take 1 as a common factor, that'll give you 1 times x plus 3. If we combine the two terms, then we have 3x plus 1 times x plus 3 equals 0. X is equal to negative 1/3 or negative third. Just that simple, isn't it? All right, let's go to the next one. 3x squared minus 11x equals negative 10. Just like how we did in the previous problem, we can add 10 to both sides, which would lead us to this following expression. We want 30x squared when we multiply, but then when we add or subtract, we need to get negative 11x, right? How could we do that? Well, if you multiply negative 6x times negative 5x, then you end up with plus 30x squared. At the same time, when you add negative 6x and negative 5x, then we end up with negative 11x. So substitute this in place of negative 11x should give you 3x squared minus 6x minus 5x plus 10 equals 0. If you split this in 2 halves, and if you take 3x as a common factor, it's x minus 2. If you take negative 5 out of the bracket, then you end up with x minus 2 equals 0. We now have 3x minus 5 times x minus 2 equals 0. We can have x equals 5 over 3 or plus 2. Both are valid values. Okay, the question doesn't say whether the number is rational or whole number or any of that sort, so both of these values are correct. All right, I particularly like this problem because to arrive at a quadratic expression, you have to make some substitution. And then from the substitution, you end up getting a value of the intermediate value from which you get the value of x. From there, you actually end up in the final answer for the problem. All right, the question asks you, what is the sum of the values of x that satisfy the following equation, which means you need to figure out two values of x. When you add them, you get a value, and that value is the final answer for the problem. So we have 16x power x minus 10 multiplied by 4 raised to the power x plus 16 equals 0. Now we have to use our existing knowledge of exponents. So 16 raised to the power x can be written as 4 squared power x. Now why 4 squared? Because our x squared term and then the term following also has 4 to the x. So we are trying to solve the problem in terms of 4. So 4 squared times x minus 10 raised to the power 10 multiplied by 4 raised to the power of x times plus 16 equals 0. Now what I'm going to do is, instead of writing 4 squared power x, I'm going to write it as 4 power x raised to the power 2 minus 10 multiplied by 4 raised to the power x plus 16 equals 0. Why did I do that? A raised to the power b, the whole thing raised to the power x is a raised to the power b times x. Similarly, a raised to the power x, the whole thing raised to the power b is a times b to the x. So these two terms are equal. So these are interchangeable, and that's exactly what the concept I used here to solve the problem. So now we can say that, say a equals 4 raised to the power x. Then this whole expression simplifies to a squared minus 10a plus 16 equals 0. So we want negative 160 a squared and we want negative 10a, right? So how could we go about doing this? So we want 160 a squared, but at the same time we also want 10, right? Isn't that correct? Right. Sorry, this is 16a squared. I'm sorry. That's what I was wondering. Okay, 16a squared, and we want negative 10a. Okay. So what two terms we can multiply? Well, we can multiply 20 times 8, right? So if you multiply negative 20a times plus 8a, then we end up with negative 2 times negative 2a. Let me strike off everything. Okay, let me just redo this whole thing. It's getting a little confusing here. All right, we want negative 16a squared and we want negative 10a, right? So if you multiply negative 8a, right, times, sorry, we want plus 16a squared and negative 10a. So if you multiply negative 8a times negative 2a, we get plus 16a squared. At the same time, if we add these two terms, then we get negative 10a. I apologize for the little mix up here. So now if you substitute negative 8a minus 2a in place of 10a, then we get a squared minus 8a minus 2a plus 16 equals 0. If we take a out of the bracket, then we get a times a minus 8, and we take minus 2, we get a minus 8. We get a minus 2 times a minus 8 equals 0. A is 2, a is 8, right? The problem's not over yet because we substituted a in place of 4 raised to the power x. So what we could do is 4 raised to the power x equals 2. This is the first part of the problem. 4 can be written as 2 raised to the power 2 equals 2 raised to the power 1, which is same as 2, right? Why did I do that? You will see in a minute. So this is same as writing 2 raised to the power 2x equals 2 raised to the power 1. If the bases are same, then the powers should be equal to 0. 2x equals 1, x equals 1/2. Similarly, I'm going to write the other part of the problem here. 4 raised to the power x is 8. 4 is 2 raised to the power 2 raised to the power x. 8 is same as 2 raised to the power 3. This can be further written as 2 raised to the power 2x equals 2 raised to the power 3. 2x equals 3, x equals 3 over 2. The question asks you the two possible values of x when it added up, what is the final value? That means x equals 3 over 2 and we have 1 over half. If we add 3 over 2 plus 1 over half, we get 4 over 2 equals 2. So the final answer is 2. I like this problem because it really makes use of a lot of concept. It makes use of substitution. It makes use of exponents. Okay, it makes use of ratios. There's just a lot of things happening in this one problem. So hopefully you enjoyed the problem as much as I did. Even if you didn't enjoy the problem, hope you learned something from it. All right, let's go to the next problem. This is the last problem in this video. We have more videos on this topic of factoring quadratic equation. So let's do the last problem in this video. We have two expressions, f of x and g of x. The question states, if k is a negative number such that f of k equals 31, then what's the value of f of g of k? Okay, first we need to figure out what f of k is. Why is that? You'll see. Okay, because that expression, what you get for f of k is equal to 31. Now, neither of the expressions f of x or g of x is equal to something. We can't say it's equal to 0 because k is presumed to be a negative number. So f of x, okay, equals 2x squared minus 4x plus 1. When you say f of k, we're substituting the x in place of k. So 2k squared minus 4k plus 1. This is equal to 31. So if you add, if you subtract negative 31 on both sides, then you get plus 1 minus 31 equals 0, right? So that's 2k squared minus 4k minus 30 equals 0, right? So we can substitute, we can reduce it even further. So if we take 2 out of the brackets, k squared minus 2k minus 15 equals 0. 2 is irrelevant, so we can disregard it. Now we can solve what's within the bracket. So we want negative 15k squared. We also want negative 2k, right? So if you multiply minus 5k and plus 3k, then we end up with negative 5 squared. And if we take negative 5k and add 3k, we end up with negative 2k. So let's go ahead and substitute this expression, negative 5k plus 3k, in terms of negative 2k. So that will be k squared minus 5k plus 3k plus, sorry, negative 15 equals 0. So if we don't need to do this. So if you break this in two parts, then if you take k out of the bracket, it's k times negative 5 plus 3. If you take it out, it's negative 5. This whole thing is equal to 0. So k plus 3 times k minus 5 equals 0. K equals negative 3 or 5. The question states k is a negative number, so k equals negative 3 is what we're going to work with. Okay, so we now have to figure this f of g of k, we need to figure out g of k because it's the first term within the bracket. So g of k equals, it means k is now negative 3. So g of negative 3 equals what? G of negative 3 is nothing but negative 3 squared plus 16 raised to the power half. So that's 9 plus 16 raised to the power half is square root of 25, which is same. It's essentially the same thing, so we get 5, right? So g of negative 3 is 5. So g of k is equal to 5, right? So f of g of k is f of 5. That's what it really translates to, right? We're substituting g of k as 5 in f of g of k. So f of 5 is 2 times 5 squared minus 4 times 5 plus 1. So this is 25 times 2 is 50 minus 20 plus 1. So that's 31. It's a lengthy problem, but it's very important you can solve such a problem. These sort of problems genuinely has the quality of being on a SAT exam. So hopefully you learned something in this video, and I'll see you with another video on factoring quadratic equations. So stay tuned.